Hello, everybody, and welcome to this new webinar from CRP. We're going to be talking about space mission innovation boost with Windform materials, these high-performance composite materials for SLS 3D printing. Now, let's start with the agenda of this webinar. Today, we're going to start talking about CRP Group and the available technologies we have. Then we're gonna see a picture of the different industries where we work at. We're gonna have a view to our facility of production. And then we're going to start talking about the Windform materials and their case studies and the applications of these materials. Finally, I will pass to my colleague Alessio Bondi to talk about CRP latest news. And at the end, we will give you our contacts and we will have a question and answer session. Let's start, everybody. Well, CRP is a group of different companies. We have CRP Mechanica, CRP Technology, and CRP USA. On CRP Mechanica, we are specialized in CNC machining of special special metallic materials and alloys, and DMLS technology. On CRP Technology, the owners of Windform Materials, we are specialized on SLS material technology for 3D printing, where we have the capability of serving our clients as a service bureau for different components, or to sell the Windform powders to companies having compatible SLS machines. For the US market, North American market, we have our sister company, CRP USA, which does exactly the same as CRP Technology, but for American clients. Here you can see our headquarters. We have CRP USA based on Mooresville, North Carolina, near to the motorsport industry in the US. Then we have CRP Technology and CRP Mechanica based in Modena. Modena is a very industrialized area on the northern part of Italy, near to different companies, mainly from the automotive industry. Here are some industries where you can find SLS parts done with Windform materials, which we supply. These are aerospace, avio, and drones, UAV industries, which we will be talking later on, and also on motorsports, automotive, and other sports industries. Now, let's get to the point of this webinar. Let's start talking about our high-performance composite materials for SLS additive manufacturing technology. Well, let's start with the capabilities, the machines we have in our CRP Technology and CRP USA companies, from which we can serve you as a service bureau to produce and manufacture your components. In Italy, we have 10 different sinter stations. 3 of these are what we call large frame machines, with a capability of printing up to 550 per 550 per 450 millimeter components. So imagine a cube of these dimensions where you can place your parts on. Then we have another 6 small medium frame machines with smaller dimensions, which are 350, 320, and 400 millimeters, a cube of these dimensions. And we have a small machine, which is 280 per 140 per 180 millimeters, which we use mainly for the development of our materials. On CRP USA, we have another 5 sinter stations composed of 4 small medium frame machines with dimensions the same as the one we have in Italy, and 1 large frame machine with capabilities of more than 400 per 400 per 500 millimeters. On the top right of your screen, you can see this is the facility from CRP Italy. These are the different machines These are the small medium frame machines. And on the back part, you can see our facility in Mooresville, North Carolina, with the 5 different SLS machines. All of our facilities and our companies are certified ISO 9001. So we're ready to work for you. Now, here we can have a small view from our materials. This is our top line of materials, let's say the materials that we are most suitable for the aerospace industry and production. We have the Windform XT. Let me show you. I have here with me the material, the part that you can see in the picture. It's a small CubeSat. It was done with Windform XT. Some characteristics of these materials are the low density and the heat deflection temperature of 173 degrees. Also, the tensile strength, top of the class for this type of materials, is almost 84 megapascals on the x-axis. It's very suitable for manufacturing aerodynamic parts due to the rigidity of this material, and also for CubeSat, in this case, due to the strength, the stiffness of the material. Then I also have this very important component. This is a massive, this is an intake, a intake manifold developed for an engine. A good characteristic of this material is that it can be furtherly machined, and as well as that we can place some metallic inserts into the part. As you can see, we have some special inserts, and we have some helicoils as well on the structure, enabling to fix other components into this part. And another thing about this material is that the structure of the cells from this material are very close, so you can have waterproof, watertight materials components. In this case, this manifold intake was tested on an engine on real life conditions, and it was standing up to 4 bar pressure inside the part. So it was really useful for the development of this engine, and the final approved by the constructor and then launching all the molds for the final injection. These 2 materials, which I talked to you before, are carbon fiber reinforced polyamide based materials. Now we're going to talk about the 2 materials on the right side, which are the glass fiber reinforced materials. We have the Windform GT, which is a really elastic material. I have this part, which is from a prototype from the Bebop drone from Parrot, which we help develop with different iterations. We suggest this material to Parrot because of the flexibility of the component. They had several drones crashing on and destroying themselves. With this material, they get to test them, and due to the flexibility, to the stiffness, the flexibility and the resistance of the mechanical characteristics of this material, they quite resist a lot and help them develop in a faster way the components. You can see also that the tensile strength is really good, around 56 megapascal on the tensile strength on the x-axis. And you can also see, well, probably you don't get to see it, but you can order some parts and see it on yourself. You can have a really smooth finishing of the surface with this material. Also, location to break is almost 15% of the material, so really flexible. On the other side, we have Windform LX 3.0, which is another glass fiber reinforced material. It's It's design. It's very useful when we are talking about mounting electronics. This is a case study from our partnership company, Energica Motorcycles, developing electric super bikes. So in this case, it was a fuse support. There was a high voltage passing across this component. The fact that it was CTI 600 index certified helped developing this component. So whenever you're planning on placing electronics and batteries into your components, we can help you develop them with this material. Also, the tensile strength of the material is really good. As you can see, all these four materials, they're having this black material, colored material, which is really good for making prototypes, so they cannot hatch your prototypes. Also, a good thing about these four materials is that they have passed the outgassing test for different space agencies like NASA and ESA, and JAXA as well for some components, and that's it. Now, a couple of years ago, due to the needs of the aerospace, especially in the avio industry, we decided to prepare these two materials, which have flame retardant capabilities. We're talking about the FR1 and the FR2, which both pass the FAR 25853 12-second vertical and 15-second horizontal flammability test, as well as the 45 degrees Bunsen burner test. These components are really good for developing. We're talking about pipes and conducts around the aircraft, especially for the cabin interiors, and for so many other applications requiring fire resistant applications and materials. So in this case, you can have a duct having no internal supports in it. That's the advantage of this technology. And in this case, not having the support, you can have nice ducts without having the fact that the internal surface will be compromised due to the support stacking into it. So you can see also the density is really low for this material. The melting point is really good. The tensile strength is around 65 megapascal, so really tough. This is a carbon fiber reinforced material. Okay, and it's certified V0 as the UL HB rating. On the other side, unfortunately, I don't have it here with me, but we have this FR2 material, which we developed these cell supports for the Energica racing superbike, racing on the Moto E championship. Okay, this is a really special component, having the capability of non-conductive material mixed with the flame retardant, which was a good feature, especially for developing electrical batteries. You know, in some, when they're pushed into the limit, you can have some venting phenomenon, which can release some heat, and obviously the fact of having a flame retardant material will help on all the battery pack having the capability of the possibility of starting a fire. Okay. Now let me just talk about 6 good reasons why you should consider our composite Windform materials on your next project. First of all, because we have the best tensile strength per unit in the market with our Windform XT. You can have a really light material and really stiff and mechanically upgraded material. You know, we know that in in the aerospace industry. The density, having low density, as we can see on the other feature, is also really good value for the parts. We can also have several compliance and certificates, like outgassing, the vacuum ultraviolet certificates from different space agencies, the CTA tracking index, the UL94 certifications for our materials. This is also a good fact that you can already have certifications and validation of our materials for different applications. Another reason why is the high resistance to temperatures. We know that our materials are used for different applications in space or near the engine. So we're talking about from minus 50 degrees or for up to 150 degrees. We have case studies talking about our materials on these applications. We have our materials that have excellent mechanical and electronical capabilities. And finally, the fact that this Windform FR1 is the only flame retardant material for laser sintering technology that you can find on the market. You can find more information about these facts, about the certifications. You can find the data sheets from our material for more information on the specific data. You can have some more information on the thermal expansion, thermal features on our website. It's www.windform.com. Go and check it. Finally, let's talk about our case studies. We'll be talking about different case studies on the aerospace, mainly on satellite applications, another application on the avio industry, and finally, one application on one of our favorite drones. It's the EXA drone. Now, let's start with the case study number one. This project was developed with Alba Orbital, who is a fast-growing high-tech company based in Glasgow, Scotland. Alba Orbital provides deployer for Pocket Cube satellites, but not only building their own platforms, but providing parts and launch to companies, university, and space agencies around the world. The aim of the project was, as per any aerospace part, minimizing the weight, which is fundamental. Also achieving full manufacturability, implementing a number of safety features, as well as achieving flight approval following the strict rules regarding degassing on space. The solution, as the product needed to withstand a launch to space while containing several satellites, the pod had to withstand high vibrations. And in the worst scenario, containing any satellite that breaks free in the internal of the pod. In this case, we suggest use the Windform XD 2.0 due to the toughness and strength in making it a perfect candidate for this severe case. A result, once we receive the 3D files from Alba Orbital, we get to manufacture this Alba pod in really short time, waiting less than 500 degrees. The most innovative aspect about this project was the number of components that were switched from the initial project to Windform XD 2.0. Not only the shell was redesigned for the material, but also the moving ejection mechanism launching the other satellites and the door assembly. These parts were critical for the functioning of the deployer, and they were assembled as a whole in all produced in Windform material. You can see the space mission at the beginning of the 2019. It was the Alba pod was launched, containing 6 different Pocket Cube satellites inside. Now the Alba Cluster has been orbiting for 100 days, and we're expecting COVID allowing everybody to perform their activities at the best for the next launch of Alba Pod version 2 on this spring summer to 2021. Now let's talk about next case study. Yes, case study number 2. It's a MiniCube space qualified 1P pocket cube, a space ready nano satellite. This second case study was developed with MiniCubes LLC. A company was founded in 2018 to take the concept of pocket cube and develop it into a viable product on the principle of the virtually anybody can reach the space today. Joe Luttrell, the CEO of MiniCubes, and his team turned up to CRP to the manufacture of the entire satellite frame with additive manufacturing. And the result was this 1P pocket cube named Discovery. The main challenge was related to the small dimension of the satellite and the material being the first time used for to build an entire satellite with carbon composite materials. Discovery is a pocket cube satellite, a small spacecraft having an internal volume of 50 millimeters per 50 millimeters per 50 millimeters. The challenge was to fit all the electronics, camera, and radio system into it, being such a small component. The solution was an entire satellite manufactured with Windform XT 2.0, our carbon fiber reinforced material. Performance is everything. So if any small part fails, the rest of the mission and the spacecraft could have failed. So the combination of the strength and the ease of use of the material was a natural choice for our partners in MiniCubes. Moreover, Windform XT 2.0 had passed the outgassing test for the most important space engine, making this suitable for a space mission. The result was a 3D printed 1P pocket cube, functional prototypes. We print 4 of these, having successfully passed all the controls and the testing criteria of the customer and the deployer, and have fully complied with the requests of MiniCube standards. As the MiniCube CEO stated, we have run quite a few tests with many more on the way. So far, we have load tested to over 20 kilograms. The material has been vibration tested by NASA GEVS 7000 specifications, subjected to near vacuum to simulate the conditions in Earth orbit, and thermally tested from 50 degrees Celsius to minus 40 Celsius degrees. Windform XT 2.0 has passed every test we threw at it, and we are very proud about this. Now, let's talk about our final case study on the aerospace satellite applications. It's the 3D printed 3U CubeSat form factor. The company which helped us develop this project is France Laboratoire Interuniversitaire de Systèmes Atmosphériques, LISA, of University of Paris-Créteil, under the EGNES and Space Campus University supervision. The challenge was to create a structure that could survive to vibration tests, simulating the launch of the project, resist to thermal vacuum test, and also to withstand outgassing requirements. CubeSat structure is critically as it must fulfill the launchpad requirements in terms of dimension, flatness, and roughness, but also in thermal expansion and general space constraints. The solution, again, Windform XT 2.0, carbon fiber reinforced material. Their mechanical properties guarantee the achievement of the required features like stiffness, low mass, and a very smooth surface finishing. We particularly concentrate on this issue to allow the correct mounting of the deployment of the CubeSat. The result was a 3D printed 3-unit CubeSat structure that passed the validation and testing criteria of LISA standards, where the resistance to vibration and thermal vacuum test, the mass optimization, the internal part integration, and the fulfillment of the outgassing criteria. Now, let's go into our case study number 4, which is Leonardo Helicopter Division AW609 3D printed wind tunnel model. This project is related to the manufacturing of one of the most external parts of the Leonardo Helicopter Division tilt rotor AW609. The prototype scope was to test the wind tunnel several components of the tilt rotor, like the nose, cockpit, rear fuselage, external tanks, and fairings. The scale model was 1 in 8.5 per. So almost imagine, I don't know, for the ones you know, this project from Leonardo, this tilt rotor helicopter plane wise, it's almost, the mock-up was almost 2 meter in length and 2 meter wingspan. So it was a really big mock-up. The wind tunnel model was designed, manufactured, and assembled under the supervision of Leonardo Helicopter Division for a series of dedicated low-speed wind tunnel tests. The challenge was to manufacture the model in a very short deadline and with the highest level of reliability and commonability between the model configurations. Consider that this plane had different aero configurations and the possibility to test the tilt rotors on different positions. Using a high mechanical and aerodynamic characteristic material for this component was the solution we proposed with our Windform XT 2.0 material. Otherwise, they would have requested to build the material in a composite material. The most critical aspect of the project was therefore the resistance to the loads, but also the necessity to maintain good dimensional tolerance of such a large dimensioning component and their heavy forces. Especially the components of the external fairings couldn't deflect much during the test. The solution was manufacturing an internal structured aluminum and steel frame, milled and assembled with the external geometries that had been obtained with 3D printing techniques. The choice of Windform XT 2.0 composite material was not casual. All the goals required by Leonardo Helicopter Division were carefully taken into consideration. Short realization time, good mechanical performance, as well as good dimensional characteristics. The final result was in line with the delivery and functional requirements requested by Leonardo, which was finally testing this mock-up on the Leonardo's Helicopter Division wind tunnel facility at Bresso near Milan. The manufacturing time of a single part was really short. We just required 1 day to set up all the models in the printing machines and 4 manufacturing days of all the various parts and components. The final step was to complete the model surface finishing directly mounted on the aluminum structure in order to optimize the small imperfections that we could have from the union of the single components. At the end, we had a really, really beautiful result with this mock-up model, as you can see on the pictures. Finally, let's talk about our last case study on the Exadron's Tundra M 3D printed drone. The requirements by Exadron was the creation of a fast reiteration process for design optimization, the achieving of a best ratio between structural strength and weight, and the opportunity to combine multiple functionalities from the unique part. The solution, the components that combine the brains of the Tundra, the body, what you can see on the left side. The body frame is composed of main frame plus a removable top lid that were printed in Windform SP because they needed to be water resistant and watertight. Moreover, robust to support the emergency parachute cased in here. 2 batteries in the inside, as well as exchangeable accessories, as you can see, the cameras and the gimbals. Also, the thermal properties of Windform SP, carbon composite materials, help to dissipate the heat from all the electronics inside the case of the machine. The arms are composed of the motor supports plus an interlock base, which allows the users to easily tighten them to the body with a special ring into it, a special ring system. These arms needed to be stiff to allow the user to connect and disconnect interchangeable arms on a discriminatory basis depending on the length of the requirements. The Windform composite materials was used. We used was the Windform XT 2.0, and it was used due to the rigidity of the material and the mechanical properties of the part. The result was that Windform materials and selective laser sintering from CRP Technology allow to easily prototype key components of the product, to outcome the plastic injection molding process in terms of deadlines, costs, and test the prototype in real condition, including extreme weather conditions, with the mechanical characteristics required by the project. Now, I'm going to leave you to my colleague, Alessio Bondi.
Good morning, everybody. And thank you, Antonio. Now we switch a while from laser sintering of polymer to metal sintering. I'm Alessio, and I'm glad to share with you the latest news of CRP Group. It's an exclusive distributorship agreement with the metal additive manufacturing leader Velo3D, based in US. The agreement starts this January, and CRP Meccanica is now exclusive distributor for Italy and account distributor for Europe of Velo3D support-free metal 3D printers. Why CRP Meccanica has been chosen by Velo3D is because its long expertise in metal AM technologies and precision CNC machining, and outstanding skills of engineering team able to support customer with dedicated consultancy. If you're interested to know more about the Velo3D unit, don't hesitate to contact us. We'll be happy to arrange a dedicated session to unveil the extraordinary possibilities of Velo3D units. This next slide shows an extraordinary case study concerning boom aeronautics, where we have highlighted the very unique geometries achieved thanks to the state-of-the-art capabilities of the Sapphire support-free printer. Such shapes couldn't be done with any traditional manufacturing technology. Let's start with the first question. We have a question of Thomas Taubert. He said, thank you, Thomas. I read in 2019 that CRP Technology makes Windform unavailable to the 3D printing service bureaus. Is that still the case, or there are 3D printing service bureaus in the United States offering printing in Windform materials? I pass the word to Antonio, who is going to reply to your question.
Hi, Thomas. Thanks for your question. Yes, we did. We only provide Windform materials to final clients using our compatible machines. But in the US, we have CRP USA, which can give you, can serve you as a service bureau. They are actually the only authorized service bureau in the US. You can write us to info@crp-group.com, or you can just check our website windform.com. You can find all the an email and where to write us. Just and we can send you all the details of our partners in CRP USA.
I have a question now from Sergio Montenegro. Can you compare currently used materials for space structures like aluminum and your material by actual mass reduction?
Yeah, hi Sergio. Just to give you a quick response, I'm going back to this page. where you can see that the density of our materials is 1.97 grams per cubic centimeter, while if I don't go wrong, for aluminum, we're around 3.8 or 9 grams per cubic inch. So we're almost a fourth, between a third and a fourth of the density of the aluminum. Obviously, we're not telling you that the structure will be have the same stiffness. So you will need to simulate what is needed as geometries to reduce the weight on the component. But for sure, I can say that all our clients, the first reason why they choose to change having a CubeSat or a small satellite on passing from aluminum to Windform materials was because the reduction of weight and the simplicity of the questions.
Jill asked, any data on radiation dose of the electronic on board of the pocket cubes to see the difference with aluminum shielding?
Yes, Yields. Unfortunately, we don't have any direct data from this radiation dose because we are not the owners of the pocket cubes. We can put you in contact with some of the pocket cube companies that work with us and to see if they might give you some information. But I can tell you that all the pocket cubes using Windform materials, they're working correctly. They're still in orbit, some of them, and also you can read some more case studies on our website www.windform.com.
Thank you. Now it's Veronica's question. Which is the typical development and manufacturing time to have a 3D printed part? Thank you, Veronica. That's a very nice question.
Hi, Veronica. Yes, thanks for your question. The typical development and manufacturing time to have a 3D printed part, obviously it depends on the design you give us. Let's say the development depends on you. Because you're going to be the designer, we are going to suggest you some modifications and some improvements of our of your model in order to make them to make a full feasibility of the manufacturing and some considerations of our experience. For the manufacturing, since we get the goal to print the parts, it usually takes from 3 to 4 working days to print the parts and to finish them. It will obviously depend on the quantity of parts that you will be asking us to produce, the size of the parts, and so on. So hopefully I answered your question correctly.
What's the approximate structure cost for a CubeSat?
Yeah. Hi, Janice. It's really difficult to tell you which is the cost of the structure because we usually run simulations over the 3D models in order to establish the time needed to print the material needed for the part and also some finishing and some manual activities done over your CubeSat. If you have a short design and a short model, even for the aluminum one, in a couple of hours, we can give you back an estimation of the cost for your project.
Good, thank you. Now it's a question of Aravind Kilaru. Is asking, thank you, Aravind, do you ship international or any contact person in India?
Yes, Aravind, sorry, we don't have any resellers in India. We will deal directly with you. We can ship internationally. We are already shipping to every country in the world, from Argentina to New Zealand, from Europe and Asia. No problem at all.
That's another interesting question from Janice Dalbins. How much do carbon fiber reinforced material degas in vacuum?
To be honest, it will depend on which material we are talking, and it will depend on the geometries of the part. So actually, I cannot give you a punctual question. In case you have a specific project, I will suggest you maybe we can print a sample part for you, and you can run any test, specific test, for you to have a more precise answer to this question.
Are the materials tested for high vibration or sound levels like a rocket launch?
Yes, Sergio. The materials tested for high vibration. Yes, as I was telling before, there's a really nice video I was watching the other day on the Alba Pod channel, where they were testing for the NASA GENV 7000 vibration standard. They were placing the Alba Pod with all the 3D printed components inside, and doing this high vibration in simulating all the vibrations on the launch. So yes, the materials are tested. Obviously, it will depend on the final geometry of your part, no? Because if you this will require some simulations, and we will be we can give you all the information to run your all the data you will need to run these simulations. In case you can write me an email to the contacts you see there, I will give you the link to the video I was watching from the Alba Pod channel.
I remind everybody, we have limited time to reply to your question, but you can always write us with your question and we can reply in more extensive way. Now I have a question from Alex Chang. Thank you, Alex. Alan, sorry. Thank you, Alan. You mentioned a drone application. I assume the 3D printed part can be painted over for an exterior cladding application.
Yeah. Yes, Alan, for sure. All the at the end, you can consider a 3D printed part just like any other injection mold plastic part. So it can be coated, it can be water transfer, it can be even metallized with a metal plating for enhancing other features over the material. It can be easily painted. We don't do it very often because our clients like this black carbon color. So for the prototypes and for the design, they don't show everybody all the features. But in case you want aesthetically nice part, it can be painted by your local body shop, just like it was a part of a body shop from a car or any other plastic.
You're right. Now, a question about, again, Janice, is about electric conductivity. He's asking if the bare part, is the bare part electrically conductive?
The bare part, if you intend the plastic part, is non-conductive. Is a CTI 600 certified part. It's our Windform LX material. The only conductive part, obviously, in here is the fuse, and yes, this application is an application on electric batteries and high voltage application.
Okay. Then we have a question: are the materials for CubeSats prone to collecting dust in a non-clean room environment?
Well, it will depend on how much non-clean the room environment it is, but obviously you can find that the material, even though it's been polishing, there's a surface roughness on the surface. So it can collect any dust like it will do any other part, even a metallic part. But unfortunately, the materials are really easy to clean. You just need some slight detergent you can find in any store with a smooth cloth. You can clean it, and you can eliminate the grease from the part. You can eliminate the dust, and well, if you want the dust not to be collected into the part, obviously you will need to have a clean room environment.
Question from Veronica again. Do you offer a consulting service in order to indicate the most suitable Windform material for each specific project?
Yes, we usually talk with our clients just before any print or any new project, and asking them what is the application, what are the requirements, what are the specs they want to have from these parts. And obviously that our job is to tell them and to support them, telling them which are the best material we think they are for their applications. We also help them finding all the specific data they need to run their simulations. And obviously, from our experience of more than 25 years printing 3D parts with our materials, we have lots of experience of cases, and for sure, we transfer this information to our clients.
Thanks everybody for being with us in this session. So it was a pleasure.
Thank you, everybody, and have a nice evening.